section 14.6, graphing quadratic functions. The objectives: graph quadratic functions of the form y equals ax squared, graph quadratic functions of the form y equals ax squared plus k, graph quadratic functions of the form y equals a times x minus h squared, graph quadratic functions of the form y equals a times x minus h squared plus k. The definition is any function that can be written in the form y equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0, is a quadratic function. Example 1, graph each quadratic function, setting up a table of values for x and y as an aid. Choose values of x on each side of the line of symmetry. 1a, y equals 3x squared. Here for our solutions, we are going to choose the following x values: -4/3, -1, -1/2, 0, 1/2, 1, and 4/3. And we're just going to plug those values of x in and get our yielding y. When I plug -4/3 in, y is equal to 16/3. When you plug in -1, y is equal to 3. When you plug in -1/2 for x, you get y equals 3/4. When I plug in 0, I get 0. When I plug 1/2 in for x, I get 3/4. When I plug 1 in for x, I get 3. And when I plug 4/3 in for x, I get 16/3. So notice here the symmetry. Those values mirror these values. So this is the graph of our function. So here it's what it looks like when you graph each one of those ordered pairs. So we have -4/3, so that's 16/3. -1 is 3. -1/2 is 3/4. 0 is 0. 1/2 is 3/4. 1 is 3. And 4/3 is 16/3. Example 1b, y equals -1/3 x squared. So once again, we'll set up a table. This time we'll use the values -4, -3, -2, 0, 2, 3, 4. You should choose x values that have a pattern to them so you can see a pattern in your y values. When I plug -4 in, I get -16/3. When I plug -3 in, I get -3. When I plug -2 in, I get -4/3. When I plug in 0, I get 0. When I plug in 2, I get -4/3. When I plug in 3, I get -3. And when I plug in 4, I get -16/3. So here is your graph. And once again, you have -4, -16/3, -3, -3, -2, -4/3, 0, 0, and then you have the symmetry on the other side. Example 2, find the line of symmetry and vertex for the quadratic function y equals 2x squared minus 3. Then graph the function, setting up a table of values for x and y as an aid. Choose values of x on each side of the line of symmetry. The line of symmetry is going to be x equals 0. This parabola opens upward since a is positive. And the vertex is at 0, -3. So looking at our table of values, we're going to go -2, -1, -1/2, 0, 1/2, 1, 2. When we plug in -2, we get 5. When we plug in -1, we get -1. When we plug in -1/2, we get -5/2. When you plug in 0, you get -3. When you plug in 1/2, you're going to get -5/2. When you plug in 1, you're going to get -1. And when you plug in 2, you're going to get 5. So this is what our graph looks like, where the dashed red line is your line of symmetry. It's the line that cuts the graph into 2 equal pieces. Example 3, find the line of symmetry and vertex for the quadratic function y equals negative x minus 5/2 squared. Then graph the function, setting up a table of values for x and y as an aid. Choose values of x on each side of the line of symmetry. The line of symmetry is x equals 5/2. And the vertex is 5/2, 0. And these are formulas that are on your formula sheet. Also, when you understand which form you have your quadratic equation in, some of those things can be read from the actual equation. Note that the parabola opens downward since a is negative. This is the a value, -1. So we choose values for x and y. 0, 1, 2, 5/2, 3, 4, 5. When I plug in 0, I get -25/4. When I plug in 1, I get -9/4. When I plug in 2, I get -1/4. When I plug in 5/2, I get 0. When I plug in 3, I get -1/4. When I plug in 4, I get -9/4. And when I plug in 5, I get -25/4. And so this is what our graph looks like. Example 4, find the line of symmetry and vertex for the quadratic function y equals negative x plus 2, that quantity squared, plus 1. Then graph the function, setting up a table of values for x and y as an aid. Choose values of x on each side of the line of symmetry. Your line of symmetry is x equals -2. The parabola is going to open downward since a is negative. And this is your line of symmetry. You set that equal to 0. The vertex is -2, 1. That's h, that's k. Our table of values are going to be -5, -4, -3, -2, -1, 0, 1. When I plug in -5, I get -8. When I plug in -4, I get -3. When I plug in -3, I get 0. When I plug in -2, I get 1. When I plug in -1, I get 0. When I plug in 0, I get -3. And when I plug in 1, I get -8. So this is what my graph looks like.